birthdays, something that we all have, but we don't know what to do about it. This, this is not a video about that. Have you ever wondered, in a room of 23 people, how likely are 2 people going to share a birthday? No, I have not either. In a room full of 23 people, there is a 50% chance that two people are going to share similar birthday, right? This is called birthday paradox. Now, why is it called a paradox? This is called a paradox because it is counterintuitive to our brain. It's called veridical paradox, where anything that seems absurd or counterintuitive, but it is actually true. The real paradox is, how does 23 people out of 365 days in a year has a more than 50% chance to share birthday? Because it seems like there are so many unique days, and 23 seems like a very small number when it compares with 365 days, right? Like, how is it possible 50% people will share more than 50% chance of 2 people sharing a birthday? Well, I want to mention one thing here. It's not about you sharing a birthday with other people. It's about, among 23 people, there is going to be at least one pair of 2 different people that are likely to share a birthday, right? So let's just look into the maths of it, right? First, we're going to find the unique birthdays. So there is only one possibility where all of 23 people are going to have unique birthdays. So if we find the probability of uniqueness among all the people, then if you subtract 1 from it, we are most likely going to find the probability of finding at least one pair of sharing birthday. There could be multiple pairs, but we're going to find at least one pair, right? So in order to find the distinct pairs, what we're going to see is, like, how many pairs can be formed out of 23 people, right? So if there are 2 people, there is only one pair that can be formed. If there are 3 people, suppose we have A, B, C, so only 3 pairs can be formed. So 3 unique pair which can share birthday, right? That can be formed. If there are 4 person, and we want to find how many pairs can be formed, which is 6. For 23 people, there is a formula, n into n minus 1 by 2. So there are 253 pairs among a group of 23 people, right? So if we want to find what is the distinct probability for having unique birthday, all of them have a unique birthday. So if you try to find for first person, so first person in a room, when they walks into the room, they have 100% probability of having unique birthday because they're the only person, right? For the second person that walks into the room, for that person to have a unique birthday, they have to choose any day other than the day that first person have birthday, right? They can choose any other day. For the third person, they have to choose any other day other than first and second person. Similarly, if we find all the probabilities for 23rd person, it will be this. Now if we try to find the different, which is distinct, all the person will have unique birthday. If you find the probability, we are multiplying all of them. So every time a new person walks in, they have to maintain the probability of the previous one. So for the second person, it was 100% before. For the second person, it is 99% of the 100%, right? For the third person, the probability is going to be 9945 of 9972, right? It is this percentage out of this. So every time a new person walks in, they have to maintain the probability of the previous one. Hence, we are multiplying all of them. All of them. And finally, we get this as the unique probability. So this is, so 49% of, there's a 49% chance all of them will have unique birthday. So if we subtract 1 from it, we get 51%, which is more than 50% chance that 2% is going to share a birthday. At least one pair would be there. It could be more than 2 pairs. If all of them share, then it will be 253 pairs. Okay. Thanks for watching.